Now we consider the mechanisms that are used by TCP to control the flow. And what we speak about is the sliding window protocol, which helps TCP to adjust to changing load situation in the network. We already know that TCP is adaptive in the sense that it adapts the speed of transmission to the situation in the network. And in detail, to regulate the flow over a connection, the sliding window protocol is used. What's the idea behind? The sliding window protocol works with adaptive load-independent windows, so-called windows. We will see soon an example. They tell TCP in how large the portion may be that are transmitted over this virtual connection to the sender. So the sliding window protocol that works with, the name already said it, with windows, whereby the acknowledgement and the window assignment are decoupled from each other. To understand this, it's best to consider an example. So the next slide, we will discuss the following example. We have sender and receiver. Let's call sender A and receiver B. And let's assume that the message has a length of 2,500 bytes. And this message should be transmitted from A, sender A, to receiver B via a TCP connection with a window size of 1,500 bytes. The window F equals 1,500. A starts with sending and takes from the 2,500 bytes the first 1,000 bytes and sends this to B, the receiver. B receives this 1,000 bytes, places them in the input buffer, and adjusts his window size from 1,500 to 500. And the 500 is simply received because with the window size you can imagine that the size of the input buffer, that's the size that B can guarantee to receive. That means if we have a window size of 1,500 bytes, then the input buffer on B has a size. And now when B receives the first 1,000 bytes, B computes the new window, 1,500 minus 1,000, it is 500. B communicates this window size to A. It acknowledges the receive, it acknowledges the receive of the 1,000 bytes, and it sends the new window size, and now the new window size is 500. The idea is to decouple the communication speed from the processing speed. Of course, the messages need to be processed on B. But in the first moment, when the message arrived, it is placed in the input buffer, and now B has an input buffer remain of 500 bytes. After A receives the acknowledgement of the first 1,000 bytes and the new window size 500, A transmits the next 500 bytes according to the allowed window size to B. B takes this 500, and let's assume the first 1,500, the first 1,000 bytes are not processed. Then now window is 0, because the input buffer is full. So B sends the acknowledgement to A together with a new window size, and the new window size is 0. Now it makes no sense that A continues to transfer the remaining 2,500, the remaining 1,000 bytes. Because window size 0 signals that B has no space in the input buffer for new arriving message. And if A would send new messages, then B could not put this information into the input buffer, so the send message would got lost, and no acknowledgement would be sent to A, and E has to retransmit. So not to perform such useless retransmission, A has to wait. A has to wait up to the moment that B has finished the reading of the first 1,000 bytes from the output buffer and resets the window size back to 1,000 bytes, and now sending the corresponding message. First 1,500 bytes are received, and new window size is 1,000. And then, you remember, there was the rest of the message. It was exactly 1,000 bytes. A now can send the rest of the message. There's a good chance that if this message received in time, then this message can be stored in the input buffer, and B can, in this way, acknowledge the receivement of the full message. So the idea of the sliding window protocol is to control the portion of data that are transmitted, and to make sure that there is no useless transmission. Useless in the sense that even if the transmission works fine, the receiver is not able to take this message into its input buffer, and then message is lost, no acknowledgement, and retransmission has to start. So the sliding window controls the flow, the speed of data transmission, in a sense to efficiently use the network. If we see this example here in a picture, then we have our sender, we have receiver A and B, and sender A sends the first 1,000 bytes. B receives this, puts this in its input buffer. The wall size of 1,500, so 1,000 is smaller. So B sends back 500 as a window size 500 together with the acknowledgement, and then the A can send the 500 and so on. Now there is, after we have understood the principle of this sliding window protocol, there is some problem. And this problem is known as a silly window syndrome. And the problem is that as soon the window size adjusts to 0, then, and the first bytes are taken out, then without extra measures, the small new window is communicated to A, and A sends only a small portion of the data that A has to send to B. So the efficiency of the use of the network decreases very much. For that reason, there is, to solve this silly window syndrome, that the window size is around 0 or over all the transmission time. The receiver gives the feedback of the available window only when at least 50% of the maximum window size is free again. So B is waiting as long as at least half of the data are taken out of the input window before it sends the acknowledgement back to A and telling A the new window size. This is to avoid that there are only tiny portions of the message are transferred with this over the internet with this mechanism of acknowledgement and others. So silly window syndrome is avoided by this strategy that receiver is allowed to send back the new window size only first when at least 50% of the maximum window size is free again. In this way, the sender ensures that the window size available is fully used.